Okay, I want to welcome all of you, to our February 2023 TAM Customer Webinar. We organized this webinar around topics that we think are interesting and helpful to our TAM customers to allow you to stay current and get the most out of the VMware products that you have entitlement to. Before we get into today's content, just a couple of items to note. As you see on the intro slide in front of you, our next TAM Customer Webinar will be on March 23rd, with the topic being apps everywhere. And Jeff will help us understand the current solutions to make your applications available to your users, some of the newer offerings. We want to keep this session interactive and make sure that your questions get answered. And the best way to do that is for you to use the Q&A feature of Zoom. If you put your questions in there, we'll make sure that we track those through the session, and Pete will be watching that, and we'll make sure those get answered. At the end of today's session, you're going to be prompted to fill out a simple 2-question survey related to the value you received from this session and any topic suggestions that you have. Your completion of this survey is really helpful, both to justify to our leadership the time we spend organizing this, but also to get your feedback on what you want to hear about. So please do take a minute to share your thoughts. And lastly, this webinar is being recorded, and your TAM can make the recording link available to you. We do keep these recordings private for a couple of months so that our TAM customers have exclusive access, and then we do release them publicly on the VMware TAM Services YouTube channel. So I'd encourage you to click that QR code in the corner or go to the VMware TAM Services YouTube channel and subscribe, and that way you can stay current with the content that we release. All right, so this brings us to today's speaker and topic, which is vSAN 8. So vSAN 8 was released in the last half of 2022 and has been one of the largest steps forward of any release in vSAN's history. One of the people best equipped to walk us through these changes and why they matter is Staff Technical Marketing Architect, Pete Koehler. And we're grateful that he took the time to join us today. Pete, the stage is yours.
Fantastic, Andy. Thank you very much. And hello and welcome everyone to this presentation where we're going to talk about what's new with vSAN 8. And in particular, really sort of the revolutionary introduction of our brand new architecture known as the Express Storage Architecture. And that's going to be the primary focus of this presentation. Just as Andy mentioned, I do have the Q&A box up on my screen. And so if you do have any questions, feel free to enter them in there, and I will do my very best to address those when it makes most sense. So for us to really better understand the effective improvements that we've introduced with vSAN 8 and specifically the Express Storage Architecture, we need to kind of take a step back to really understand how the technology, the industry, and how our customer needs have changed. So let's sort of rewind the clock a bit and look back to the way that things were about 10 years ago. And we need to kind of remind ourselves that spinning media was the dominant media at the time. And yes, there was flash, but it was small in capacity and large in price. And that's not the combination that anybody wanted. It was also hampered by legacy bus protocols or interfaces. Commonly SAS and SATA. Those hampered the customer's ability to exploit the full capabilities of NAND flash. Computational power was certainly a lot less, as well as networking. The venerable 1 gig networking was really the most prevalent networking speed that you would see inside the data center. And for a hyperconverged arrangement, that had a material impact on what systems could offer in terms of overall performance. Now let's fast forward and see what things look like right now. And flash is very different than it used to be. One of the primary differences is that we're using a brand new bus protocol or interface known as NVMe. This gives us the ability to really take full advantage of some of the capabilities in these modern flash devices. And there's also different kinds of flash out there. Certainly the introduction of very value-based high density QLC NAND flash is coming to market, and we wanted to be really mindful of that. Computational power certainly has increased a lot, and networking has completely changed. We're seeing the rapid adoption of 25/100 gig networking throughout the data center, and that, again, because of a nature of a hyper-converged arrangement, that really changes the equation and what can be done. Now, we also know that while these resources are much faster than they used to be, there's higher demands on the underlying systems. You may have data services such as encryption and compression to make this data more secure and more space efficient. So we're asking much more of the hardware than we used to over a decade ago. And lastly, these infrastructures live in multiple locations, more than just the on-premises data center, as we're VMware vSAN certainly is running out in the cloud as well. During the time that vSAN was introduced, and since that about 2014 was the initial introduction of it, we've also paid very close attention to what some of the demands have been from our customers. That has included the need to make things as fast as possible. Oftentimes we hear from customers initially saying, okay, performance is not their highest priority. They want something very value-based. Well, they get something very value-based in their environment, and then it may not be high performance enough. And so we really took that to heart and looked at how we can make things better in that regard. We've also learned some things as well. And with the introduction of NAND flash over the years, there have been new techniques and new ways of writing the data much more efficiently that have been specifically tailored for NAND flash. It's very different than spinning media ever was. And so there's a lot of lessons to be learned from there. But also, we understand that as you're introducing these really high-performing storage devices, that has a tendency to shift the bottleneck into other locations. And we needed to think about how this might impact our thoughts in a design of a new system. So we really saw all of this as a brand new opportunity, an opportunity to build out a hardware optimized architecture, and one that could easily scale and grow with some of those newer, faster, and higher density storage devices, while also making things a little bit easier for our customers. We know certainly that you can have an extremely high performance solution, and it may have a lot of features, but if it is not easy to use, that is something that is not going to show itself well for many of our customers. So that was really the motivation behind the introduction of the new vSAN Express storage architecture. This is our next generation storage architecture that was really built specifically for these high-speed storage devices, the high-speed networking, and hosts with higher levels of computational power. Now, this is an optional or an alternative architecture to what we now refer to as the vSAN original storage architecture. That's the architecture that has existed within all previous versions of vSAN, as well as vSAN 8. And this offers a lot of flexibility for our customers as they're transitioning to this newer hardware in their environment. Now, it's initially available when customers are running qualified hardware that has been approved for the vSAN ESA, and that's through the vSAN Ready Node program. Now, the nice part about all of this is that as we're going to be stepping through some of the technical nuances and capabilities that it has, the good news for our customers is that it's built right into the software that you already know. So a lot of the capabilities that I'll be showcasing are sort of under the covers and do not really change any of the operational aspects of having vSAN in your environment. In fact, there's some areas where we've simply made it easier to use. So we'll be looking over some of the specific benefits in a little bit more detail, but you're going to see some common themes that come up here with the ESA. One is this idea of being able to have a performance without a trade-off, meaning that you can store the data in a highly efficient, highly space-efficient way without having those compromises in storage performance. So this fundamentally simplifies matters for those who are responsible for these various workloads that live in an environment. Now, efficiency is not only just space efficiency, but it's also the amount of resources that are used. And this is also a tremendous improvement that we have with the express storage architecture versus the original storage architecture. This will essentially allow you to run more workloads with less hardware. And that means that you, in a sense, you are able to have a cluster running the very same workloads with fewer servers. Now, because of the new architecture, it also allows us to do all kinds of new interesting things. One of them was an introduction of a brand new snapshotting engine that has really completely changed the game for us and our users already in some of its capabilities. And I'll certainly show some more details around that. And then finally, from the simplicity standpoint, being able to make things easier to use. This has been a little bit of addition through subtraction, eliminating some of the operational tasks that a traditional vSAN administrator was responsible for. Now, you might think, how does the express storage architecture line up against the original storage architecture within vSAN 8? Let's take a look first at the original storage architecture. This was sort of built off of this idea of a dedicated caching tier and a dedicated capacity tier. And this was sort of loosely known as a two-tier architecture. Each tier had its own responsibilities. One was to provide a reasonable amount of performance, and the other was to provide capacity using more value-based storage devices. And this was really built to accommodate spinning media and a lot of those older, wide-ranging storage devices. And we were able to achieve this through the use of what was referred to as disk groups. And this was sort of a unit of storage resources that provided that blend of capacity and performance, but doing so in a reasonably affordable manner. Now, when we compare that to the express storage architecture, this is a highly flexible architecture that in vSAN 8 is using a single tier, meaning that all of the storage devices contribute to performance and capacity in the very same way. Now, this is built specifically optimized for NVMe-based flash devices. So we're not thinking about SAS or SATA flash devices in this architecture. It's purely for NVMe-based storage devices. We've been able to eliminate this concept of a disk group. And so now all of the storage devices simply contribute to those performance and capacity characteristics. And again, just kind of simplifies that administration. Now, you might be thinking, well, how do you actually transition to the express storage architecture? The express storage architecture is a cluster-based capability. So this would be very similar to when you're introducing newer hardware into an existing environment. First of all, let's say you're getting ready for a hardware refresh, and you have spec'd out the new servers that you're going to be using for that hardware refresh. You bring it in, you build up a brand new cluster. Running the new express storage architecture in vSAN 8, this can be managed by the very same vCenter server that you have for your other vSAN clusters. And at that time, you'll simply just do a vMotion and a storage vMotion of those VMs over to new cluster. So not unlike many of not unlike many of the ways that you would do for a typical hardware refresh. We don't necessarily have an in-place upgrade from an original storage architecture to the Express storage architecture. That's really because of the unique characteristics that the Express storage architecture has and the hardware requirements. So simply doing a vMotion and a storage vMotion is essentially the easiest way that you'll be able to migrate those workloads. All right, so now let's take a little bit closer look at the actual solution itself. This is going to kind of provide a nice segue to really understand some of the benefits that we have with regards to the Express storage architecture. Before I get to that, it looks like there's a few questions here that I can answer real quick. The first question from Jesse is, what is the minimum NIC speed for vSAN 8? What's the recommended speed? So vSAN 8 is going to, it incorporates the original storage architecture and the Express storage architecture. For the original storage architecture, the NIC speed minimums remain the same. So if it's still a hybrid arrangement, you can go as low as 1 gig, although I would just never recommend that in 2023. And for vSAN 8 running the Express storage architecture, the minimum NIC speed is 25 gig and in some cases, depending on what the ready node specification is, we recommend 100 gig. The good news for our customers is that the price per port on a 25/100 gig NICs is extremely competitive to what 10 gig NIC speeds are. So the push there has really come from the change in the marketplace and what is available. Joseph asks, does ESA still stripe objects over 255 gig? So there is going to be a concatenation of those components that make up an object. We lay out the data a little bit differently, and I'll certainly touch on that here in a few moments. So the best way to think about what the Express storage architecture is that it's simply a new way to process and store the data in a really efficient way. And we do that through a couple of different methods. One is that we have a really fast and efficient data path. This has sort of been revamped, and we'll look at what exactly that means here in a few moments. The second aspect of that is a highly efficient and resilient data structure. We have to be able to have the data stored in a really scalable yet efficient way. And so it's the combination of these two things that really open up the doors for us in terms of some new capabilities, new levels of efficiency, and new levels of performance for our customers. It looks like we have another quick question in the Q&A. Does using a DPU card have any performance benefit? No, the vSAN is not specifically optimized at this time for the use of DPUs. And that may change in the future. But there's one other really interesting element here about the Express storage architecture is that to process each and every IO that is being sent or received from the VM, it generally only takes about 1/3 of the CPU cycles, as you would see in the original storage architecture. So offloading only generally provides a functional benefit when you are reaching the point of contention on your primary CPUs. So that is something that is worth keeping in mind. When we think about some of the new capabilities, we need to sort of understand what we have done within the vSAN Express storage architecture. The vSAN Express storage architecture really introduced its new capabilities through two specific areas in our stack. Oftentimes we get the question of, well, this sounds like that you just rewrote vSAN. No, that's not the case at all. vSAN helps solve a lot of really interesting challenges when it comes to distributed storage, which is fundamentally a very challenging thing. We built off of a lot of that knowledge and simply revisited our storage stack and looked at how can we have an architecture that is really optimized for this latest generation of hardware. And so this comes in two primary areas. One is that we've introduced a brand new log structured file system. And this is really helps us be able to reduce I/O amplification and offer really unique capabilities with respect to the data manipulation, snapshots, and so forth. This provides a much higher level performance than what we were able to produce in the past with the original storage architecture, but we couldn't just add this new layer and then call it a day. We needed to look at the layers below it and make sure that we had a storage stack that would allow us to interface with those storage devices in the fastest way possible. And that's where we've come up with a new optimized log structured object manager, which sits at the lowest layer of the vSAN stack. And the effective result for this is that we can interface with those storage devices at near device level speeds, which is really a profound improvement over the previous architecture. Now let's look into some of the details of our patented new log structured file system as a part of the ESA. Now this is, highly technical. It's not something that you're going to need to know about the express storage architecture, but it's going to help you understand how and why the ESA is able to do things that we've never been able to do in the past. So we're going to take a look at what occurs when a VM is writing some data in the ESA. As it runs through the stack, as we receive a write from the VM, it's going to run through initially the upper layers of vSAN, and it's going to hit this brand new log structured file system. This is where we sort of ingest these writes. We coalesce them in a way that makes most sense in terms of their size. We commit this data and then wrap that data with some additional information, that being the metadata about this, about the data recently written. Now, from there, as this accumulates into what we refer to as a durable log, that data is going to be written as a fully aligned, full stripe write to several hosts within the cluster. And this offers us the ability to be able to write the data in a really quick way to that durable log and just accumulate the data, but then be able to write the data in a really space efficient way across several hosts. And what's really unique about us in this implementation of a log structured file system is that this exists on a per object basis. This is not a monolithic log structured file system. For each and every object that exists in vSAN, it has its own. And the other aspect that is really unique about this is that we have a way of storing and accessing the metadata in a really efficient manner. When you think about storing data, and especially storing large amounts of data, the storage of large amounts of data isn't necessarily the problem. The problem becomes the scaling the respective metadata about that data stored. That ultimately is one of the fundamental challenges that storage systems across the industry have faced. And this is really geared toward taking advantage of these soon to be on the market, extremely high density storage devices. So this was really built for the future in that regard. It looks like we have a few questions in the chat here. Let me address. Let's see. Yes, we have a dedicated compatibility guide for the vSAN ESA. I would recommend going out to core.vmware.com. Underneath there, you can, in the vSAN section, you'll see a dedicated ESA page, and I have laid out specific links that will help with your hardware guidance there. Lance asks, if the CPU usage is lower, why is the minimum config 32 CPUs? The configuration minimums on the hardware is simply to exploit the full capabilities of those storage devices. So we run across the very similar question that we have with regards to networking. We're actually much more efficient on the networking with the ESA than we were the OSA, yet our networking minimums are higher. In order to exploit the full capabilities of those storage devices, meaning that, like, let's say you're running a synthetic workload generator, seeing how many IOPS you can generate, that we don't want to be hampered by CPU or network. And so that's to simply exploit the full capabilities there. Let's see. Joseph asks, are there any changes to the number of objects per vSAN host with the ESA? No, there was no limitation in the objects. There were limitations in the object components, or the object component counts. That has been raised from 9,000 up to 27,000 per host. Let's see. And then another question from Cesar. I have a hardware configuration with 2 NVMe disk size, cache, and data, but for old vSAN configuration. Is a new configuration with version 8, can I configure together in a single tier? It really depends on the hardware capabilities, and that's something that we would have to look at in a little bit more detail. Okay, so that was the one aspect of that upper layer of vSAN that is new and innovative with regards to the ESA. This other aspect of it was related to the lower layer within vSAN, which is our object manager. This runs a brand new processing method using what we now refer to as a block engine that is highly parallel in its capabilities. And this parallelism is what allows us to exploit the large queues that are available with each and every NVMe-based storage device. That is going to offer us the ability to have these, massive levels of device bandwidth at predictable low levels of latency and consistency on the scaling aspect of it. You note down at the bottom of the illustration, though, you'll see that each storage device contains a combination of data. It's going to store data as well as metadata. So there's no dedicated caching tier, no dedicated capacity tier. And this will have some other functional benefits that I'll show here in a few moments. Now, you might think, well, in those previous illustrations, you may have noticed a couple of terms come up that may be new. One was this idea of a performance leg, and the other is the idea of a capacity leg. This is just our logical separation of how we sprinkle the data across the hosts that make up a vSAN cluster. And where in the past, for the original storage architecture, we had an object and we just had some components. Now we have sort of this logical hierarchy of components. And the performance leg just represents some of those initial very small amounts of data that go into that log structured file system for the purpose of our temporary writing the metadata so that we can prepare it for a fully aligned full stripe write. So here you can see that an object using a RAID 6 erasure code is sprinkled across 6 hosts, and you have the capacity leg, which is referring to all of the typical components that would normally be there, But now with the ESA, we have a performance leg, which is just the addition of 3 additional components. It's essentially a 3-way mirror that is protecting those initial writes that we are writing to the log structured file system. We can see using a RAID 5 erasure code. It's a very similar principle, but you'll just see a 2-way mirror on the performance leg. This is sprinkled across 5 hosts. And you may be wondering, well, why is that 5 instead of 4? You've thought RAID 5 was always for vSAN was sprinkled across 4. I'll certainly get to that here in a few moments. And then, of course, for a simple RAID 1 mirror, it's very similar. We still have a performance leg and the capacity leg. So this is just a fundamental difference between the 2 architectures, but from a management perspective, it is no different. Remember that an object is the smallest manageable entity within vSAN. Components are simply an implementation detail. We share them with you to help you understand concepts around availability, but there's no change in a management aspect of it. Okay, let's take a look at a few more questions here. Let's see. Joseph asks, is the durable log held in memory? No, the durable log is our log structured file system that essentially resides on those performance leg components for the object. So that means the moment that they are go into the durable log, they're persisted in a redundant way, and that's why we can send the write acknowledgement back. Let's see. Carrie asks, does using RAID 6 still have slower performance than RAID 5 with the new architecture? No, that's the concept here, and we'll certainly dive in to this a little bit more, as there's no more compromise. In fact, RAID 5 and RAID 6 is faster than RAID 1 in the ESA. So it just makes things easier in that regard. Okay, so you might be thinking, let's look at the functional benefits that you're going to see from the express storage architecture. This one is really just an easy one to kind of help understand how we were able to rethink how data services were performed. Here we have an example of what occurs when you're using the original storage architecture and a write occurs from a VM. Let's say we're also doing data services such as compressing the data, encrypting the data, as well as verifying the integrity of the data as well. As the write occurs from a VM, it's going to disperse this write in a stripe with parity across a series of, in this case, 6 hosts. Those respective data services, the compression, the encryption, the checksumming, occurs on each and every host that object resides on. Now, you can see here a little bit of a problem because we have kind of an amplification of services. Well, with the express storage architecture, we were able to rethink this, and we moved those responsibilities up near the top of the stack, meaning that when the data is initially written, or coming in from the VM, it is going to be compressed, and it's going to be encrypted, and it's going to be checksummed up at the top of the stack, so that then when it is sent to the respective hosts within the vSAN cluster that object resides on, it does not have to do that on any of the other hosts. So this is where you see a tremendous savings in resources as a result of where these services actually occur. And because it's being compressed up at the top of the stack, we're actually transmitting less data across the network. And because of how the data is being prepared, it's always being written as a full stripe write to the underlying storage, meaning that you don't have a lot of these read, modify, write steps, which are very serialized and can have some impact on performance. And this is why one of the reasons why we're able to deliver performance that is when we're using RAID 5 or RAID 6, that is faster than using RAID 1. Now, the vSAN ESA is not just about performance. Oftentimes it's about simplicity as well. And this is sort of represents an example of some of that simplicity that we bring to you. I mentioned before that we removed the concept of disk groups. That was, we heard from our users all the time about this challenge of, well, which devices should I assign as a caching device and which devices should be assigned as a capacity device and so forth. We've eliminated all of that. And now when you have a vSAN host, you will simply assign storage devices to be used with vSAN. That's it. And that can be automatic or automated, or it can be manual. That fits into this sort of administrative bucket we refer to as a storage pool. But you don't want to equate this to equivalent as a disk group, because it's not. Each and every storage device lives independently of each other. They have a level of autonomy, meaning that if there's a failure on a discrete storage device, it only impacts that device. Or if you have maintenance on that a given device, it only impacts that device. So there's a lot of simplicity here that comes from this, but it also impacts the total cost of ownership that you have for a vSAN cluster and the respective hosts that make that up, meaning that each and every storage device that you are purchasing is actually going to be contributing to the effective capacity that you have in that cluster. So that really improves the value of the ESA versus OSA. We actually are we're almost finished on a TCO paper that compares the two architectures. And you're going to find that it should be released here very, very shortly, but you're going to find that that it's a slam dunk in terms of TCO savings for the ESA for a few different reasons. And this is one of them. Now, the question before was asked a little bit about the performance of RAID 5, RAID 6 versus RAID 1, and if there's any compromises. The answer is no. And it is, in fact, faster than RAID 1 in the ESA and OSA. And this is really a result of, as writes are coming in, it hits that log structured file system. It accumulates those little segments of data, but just for a very brief amount of time, just long enough so that it can write a fully aligned full stripe write to the capacity leg. And that's how we're able to achieve really unprecedented levels of storage performance in the ESA. Let's see. Eric asks, and I'm just reading this real time, so we'll see. Since the NVMe devices use PCI lanes, have you seen issues with data congestions, throughput limitation, lane saturation when using other PCIe devices such as GPUs? Are there suggestions for configuration options on specific GPUs, available PCIe lane minimums, and so forth? No, we really haven't seen that, and there's a couple of reasons why. The effective throughput of a standard NVMe device, as far as its line rate, was much higher than past architectures and what we could achieve. Now, because of the new architecture, we can saturate a storage device, but the reality is that we saturate the network in a synthetic load generator before you ever get to the storage device. And that's why for our ready node configurations, we have the minimum configurations for a bill of materials has a ready node spec of at least 4 storage devices per host. Now, we scale very linearly on those storage devices. So you'll see higher performing ready nodes being spec'd with 8 and 16 and 20 and even up to 24 storage devices. That's going to help any of the effective congestion that you would have on those storage devices themselves. Now, you're going to be PCIe has to be the the actual subsystem, the motherboard CPUs have to be in concordance with the capabilities and the demands that you have there. So if you're doing other activities that are impacting that, there could be some impact. But the reality is that we've seen from much of our internal testing is that there's going to be other points of contention before you would run in to that. So hopefully that answers your question. Are there any minimum requirements for network switches, minimum port buffer sizes and so forth? Yeah, honestly, when you get into a 25/100 gig networking, the classification of all of the switches are just much better than what you would see in the 10 gig realm. There were so many 10 gig switches that were almost glorified consumer-based switches, and that they had some really small port buffers. They would not, or they had a shared port buffer. They had their ASICs processors were not able to process the packets per second required for vSAN. You help eliminate a lot of that with simply moving to 25/100 gig switching. So let's see. The next question is the intention to deprecate the original storage architecture in the future? No, we've had, first of all, our entire vSAN customer base has invested heavily into vSAN and the underlying hardware that runs it. And we have committed to customers large and small that we are going to be, updating and supporting the original storage architecture for the foreseeable future. And this may be up to a decade or so. But we also need to be clear that all of the new capabilities that we are able to offer are a function of the ESA's unique architecture. And that's where all of the innovation is really going to be occurring. So you can be rest assured that we are going to continue to support the original storage architecture for years to come. And while the industry and our customers slowly transition to this new hardware.
Hey, Pete. I see that Charles asked about stretched clustering. I'm going to paste a link to your blog, it looks like from December, on that topic.
Yes.
So you just
Oh,
want to
thank you very
communicate
much.
that other people can find that link in the Q&A.
Yep. One of the other interesting capabilities that we have with regards to the ESA is for RAID 5 erasure coding. This is a really unique capability that we can now optimize the size of an erasure code scheme that we're using based off of this host count in the cluster. So in this example, we have a 6-host cluster, and we have moved to what's referred to as a 4+1 erasure coding scheme, meaning the data is striped across a total of 5 hosts, the data plus a parity bit. Now, if for some reason you're removing one of the hosts from a vSAN cluster, in this particular case, maybe moving it over to another cluster or something like that, after a 24-hour period of time, it's going to reconfigure that RAID 5 erasure code to use a 2+1 scheme. So it's still using deterministic space efficiency, but offering these high levels of performance, but on as few as 3 hosts, which you could never do before in vSAN, meaning that you can have a really small cluster, but still offer tremendous and still get tremendous levels of space efficiency. A really unique capability that is going to have a real material impact for many of our customers who run smaller clusters. I mentioned earlier in the presentation, we changed kind of the location of how we perform some of the data services. Here's an understanding of what we've done with regards to our compression. First is that, yes, we have moved that up near the top of the stack. And so that is being performed once for that given write from a VM. And that means that all transmitted data that is sent across these other hosts for this full stripe write is that it's fully compressed, and we're able to get above device line rates as a result of that, because that effectively increases the throughput capabilities of a physical line. Now, we've also done something else with our compression capabilities, and we've changed how we can compress the data itself. We still use LZ4 algorithms for compression, but in the past, we would look at a 4K block and we would determine if it could be compressed by double or half of its size. We would do so. If not, we would just leave it as is. Now we can compress the data on a per sector size, so 512 bytes, meaning that we can, in theory, if the data is compressible enough, we can compress a 4K block down to as small as 512 bytes, meaning that that's a 4 times improvement over the previous implementation. So now, again, this is an opportunistic feature, so there's no guarantees on that level of space efficiency, but this is, we're setting our customers up for having much better opportunistic space efficiency in their environment. We also did something similar with regards to our encryption capabilities, in that we moved that up to the top of the stack. So the data is being encrypted as the write IO is being ingested into vSAN, and that it no longer needs to be decrypted and re-encrypted as it's hitting storage devices. We've completely eliminated that, and it's being encrypted once. So now you are saving those CPU cycles on those other hosts. It also means that the data is being encrypted as it's being transmitted to the other respective hosts. Now, we still have the toggle for vSAN data in transit encryption, and that's simply to meet some security requirements for certain governing bodies. But you can see the simplicity around this is that once you encrypt this data, and with our new optimized stack, we don't need to manipulate that data anymore. So this also reduces the amount of computational effort that is needed across an environment. Now, I've certainly mentioned simplicity on a few different aspects, and we've seen that certainly with things like adaptive RAID 5 erasure coding, where you just don't even need to think about it. That's just set. When you use a single RAID 5 storage policy, it's going to figure out what's going to be best for your environment. We also have a number of different health checks to help guide you and make sure that new ESA cluster is running in the best way possible. But also, too, we need to be mindful of that the new arrangement for the removal of the disk groups means that you have a smaller maintenance domain or a failure domain on each and every host, meaning that if you have a failure and it needs to kind of automatically regain its prescribed level of resilience for that data, it's going to have to resync less data because it's only impacting one a smaller boundary of failure. So this is something that we've already seen from many of our customers, that this has worked out very well. Now, when we have a stack that is this efficient, that we can push so much data through the physical hardware, we run into an interesting scenario, meaning that you can, if you're pushing those storage devices enough with synthetic IO generators or some unbelievable workload, then you could, in theory, saturate that network. Now, that's in part why we have higher network minimums for the ESA. But there's still going to be cases where we want to make sure that there's a fair distribution of different types of vSAN traffic over that network link. And so what we do is we have introduced a brand new vSAN adaptive network traffic shaping for these types of activities where data is being resynchronized, but there's also a lot of VMIO that's occurring. And we're going to proportionally share that network traffic or the link between those respective hosts in a real-time way, second by second, so that it can give the proportional amount of bandwidth available for the different kinds of traffic. Now, if there's no contention, there's no saturation, whether it be resync IO or VMIO, it can use the entire amount that you give it. So this is really just to help cases where it's fully saturated. Now, this doesn't mean that you can undersize your network. This is simply a protection mechanism for a quality of service. You want to make sure that you have a modern network environment that is going to be able to take advantage of the very latest and greatest hardware. I mentioned a little earlier about our capabilities with regards to a brand new snapshotting engine, and this is something that has been long needed. We at VMware even knew this. Is that we took the old redo log approach of snapshotting about as far as we could take it, but with the new architecture, we were able to come up with a brand new snapshotting engine that is very analogous to a good snapshotting engine that you would see on a storage array, where it's really fast, it's really agile. You can delete snapshots, create snapshots, consolidate them, and so forth, and it seems to be effortless. That's the way that it works in the Express storage architecture. In fact, one task that I'm sure many of you are all familiar with with the traditional snapshots was a consolidation or a deletion of a snapshot. Well, we have a profound improvement there where it's essentially 100 times faster, meaning that if you had a snapshot deletion that took 100 seconds in the original storage architecture, it would only take 1 second in the Express storage architecture. We also have dramatically lower stun times. I think it's just 1/3 the amount of time, and you have no substantial degradation once that initial snapshot has been taken, meaning that you can create additional snapshots and it's not going to continue to degrade the performance of that VM. So this has a profound effect on a lot of activities, not just backups, but think CI/CD type workflows or copy data management. Stay tuned for this area. I think there's a lot of opportunity for improvement here as well. I mentioned a few different times this idea about, well, what's going to be the effective benefit for our customers? And really one of the ways, not only in being able to deliver faster performance, is the fact that you can do more with less. And this is a great example of it. And we can prove this out even on our vSAN sizers now, is that for a cluster running the original storage architecture, let's say in this case, running 12 hosts, you might be able to run even more workloads on just 8 or 9 hosts. And that's oftentimes, and I think my colleague, he just ran through on this upcoming TCO paper that he's working on, was able to size the exact same workload characteristics from, it would be 16 nodes on an OSA cluster down to 12 nodes on an ESA cluster. So that's the effective improvement as a result of much better space efficiency and the lower cost, CPU cost, in terms of the amount of effort that it takes to process each and every IO. So that's a really compelling feature that we have there. And that really kind of showcases in a nutshell what we've done with the Express storage architecture. I know that we have a lot of questions. I would love to be able to sort of dive in to these a little bit more. And that's sort of why I went through this at the rate that we did so that we can make sure and get to your questions. So I will certainly do that right now. If you have more, this is a great opportunity for you to ask, and I'll certainly just run right through all of them. So let's go ahead and get started. Let's see. The first question I see is, may I know if existing hardware does not have NVMe and upgraded environment to vSphere 8, can the data store, I'm assuming, be updated to vSAN 8 version? Yes. So if you have an existing vSAN 7 cluster, and it's just running, whatever hardware that you have, you can do an in-place upgrade up to vSAN 8, no problem at all. It's just going to continue to use that original storage architecture. So that's just like any other upgrade that you would see in the past. It's using VLCM and so forth. So you won't have any differences there. It's when you have brand new hardware that is really geared for the express storage architecture. Let's see. The next question is, will ESA support HCI mesh and file services? Yeah, this was had a few presentations, of course, at VMware Explorer on this, and that was typically the #1 question asked. Indeed, they will. I certainly can't say when, but what I can say is stay tuned for some news very soon with that regard. Those are two very popular capabilities that we have within vSAN. We certainly understand the importance of them, and it's really just about opportunities to try to deliver that within the time constraints that our engineering team has. So stay tuned in that regard. Let's see. Joseph asks, when do you think OEMs such as Dell, HP, mixed use NVMe drives will be certified for vSAN 8 so we don't need to buy ready node configurations? Yeah, we have product managers that are continuously working with our OEMs to have a sort of a build your own approach for that as found with the original storage architecture to be there with the ESA. We wanted to initially deploy this out using the Ready Node program because it offers a basic level of quality of service or of delivery, meaning that we can guarantee that if a Ready Node is shipped as is, that this is capable of certain minimum capabilities. Whereas a build your own arrangement, we've had some customers who have introduced some hardware that was not necessarily a good match, meaning that they had really fast storage devices, but they had very few CPU cores. And so that wouldn't be a prudent way to have a design. So that the part of the goal of that Ready Node program is to have a very balanced approach on CPU, memory, network, and storage devices. But our product management team is working toward that. So sort of stay tuned. The next question is, will ESA support deduplication? With the original with vSAN 8, it does not support deduplication. From a space efficiency standpoint, remember though that customers will always be able to use RAID 5, RAID 6, and we have much better compression. So oftentimes when you think about when a person asks about deduplication, what are they interested in? They're interested in storing more data for the same given amount of capacity. And we're able to achieve that with the express storage architecture. Let's see. When there is a RAID change in your example from RAID 5 4+1 to 2+1, how does ESA compensate for that overhead without suffering the performance? So when we're making the change from an erasure code that is using 4+1 to 2+1, The data itself, the data path is essentially still remains the same, but it's sprinkled over fewer hosts. Each respective host is going to have that durable log that the data ingests those incoming writes to, and packages them up with metadata, so that then it can be sprinkled across the hosts that hold the object. Going from a 4+1 to 2+1 really doesn't change that. It will concentrate the data in fewer hosts, logically so, but it doesn't have a material impact on the performance capabilities of that from a 4+1 to a 2+1. If you had some unsupported configuration, like a single storage device on each host, you may run into some device saturation matters, but that's not a supported configuration, and that's all theoretical. So hopefully that answers your question. Let's see, Matt Mancini asks, VMware snapshots, rule of thumb has always been to remove the snapshot quickly, and they should not linger in any way. Common issues were users having snapshots for years or months, and it would crash their VMs. Has this changed with ESA snapshots? Yes, it has. So there is not that sense of urgency to delete the snapshot because the fundamental problem with the redo log based snapshots was that they were an accrual of this additional data. And so that it would have to check all of that data and sort of in a linked chain fashion. When we create an ESA snapshot, this is a series of metadata redirects. So it's essentially a redirect on write, which is very analogous to what a storage array does. So there's not that sense of urgency there. We still have a limitation of 32 snapshots, but that's not a function of vSAN. That's a function of vCenter and vSphere, and we're working with them to remove that limitation. Let's see. The next question is, does ESA require non-volatile memory? Nope, not required. How does vSAN 8 impact multi-site stretch cluster design? Yeah, so this is a great question, Eric. Thanks for answering this. Oftentimes when somebody thinks about performance and ESA, they're like, well, okay, yeah, but I have a stretch cluster that I'm going to be bound by that inner site link. I'm not going to see the benefit. You will see the benefit with the express storage architecture in a stretch cluster, especially when you're using that secondary levels of resilience, because that secondary levels of resilience, it required to write to multiple hosts in order to send that write acknowledgement back to the VM. We can do that much more efficiently within the express storage architecture than we ever could with the original storage architecture. So we're fundamentally improving the performance as a result. I wrote a blog post that focused on that implication in the original storage architecture that can be found out on core.vmware.com. And it's something that I have in the queue as far as wanting to address for the express storage architecture. Let's see. How's the vSAN ESA performance when compared to OSA for disabling dedupe and or compression? Okay, so for the OSA, the original storage architecture, there was always an implication of if you ran deduplication and compression, it was going to impact performance. In the express storage architecture, it has no implications on performance. In fact, some of our highest internal numbers come from when we are actually have compression enabled. Now, compression is on it's controlled by storage policy in the express storage architecture. It used to be a cluster-based service and is a cluster-based service in the original storage architecture. So that's where you're going to see some real benefit. It's on by default. And in most cases, unless there was a specific application that did their own internal compression, you just go ahead and leave it on. Do you know of any documentation which shows benefits of vSAN versus other storage solutions such as NetApp, VxRail, and so on? You would likely just have to look at some other vendors. That's something that's always a little bit of a challenge for us, because there's there's an ecosystem that we have to be mindful for. But I would also look at the upcoming TCO paper that we have out on vSAN. And stay tuned on that. It really should be very soon in which it's released. Let's see. When you go from a 4+1 to a 2+1, does it do a resync in the background? If so, does it set a limit on the number of devices it will perform this activity on at once? Yes. So anytime that it would see that adaptive need to make the change, it's doing a resync to do that reconfiguration. And if there is other activity that is needing those resources, it will throttle that. But if it's not, it essentially wants to get it done in the fastest way possible. So that's sort of the logic that we use there. Regarding HCI mesh in general, with the maximum VMs per vSAN host being 200, does that include VMs running on compute-only hosts that are consuming an HCI mesh data store? Yeah, this is a little bit off topic, but essentially it's the VM count is a easy to understand way of the component count limit that we had within vSAN in the original storage architecture. Remember that HCI mesh at this time is not supported in the Express storage architecture. Next question is, does ESA support hybrid Flash plus HDD or it count using OSA? So ESA does not support any hybrid arrangement. There is essentially no reason anymore to have any sort of hybrid arrangements. The price per gigabyte or price per terabyte of all flash, let alone NVMe-based flash, is such that you would want to revisit any sort of approach that called for something like that. David asks, any plans for redirect on write to VMFS? Not quite sure what you're referring to for VMFS there, but if for any sort of snapshot offloading, things of that sort. I simply can't speak to any futures at this time. Let's see. Lance asks, I have a highly deduplicated non-compressible data. Should I stick with OSA and vSAN 8, thousands of VDI VMs with same OS app fully cloned? Well, the answer is that it really all depends. Highly deduplicated can be subject. I'm not quite sure what that level is for you. But if that's the case, and you have some other, logistics there with using full clones and so forth, then you might have a case for saying, let's just sort of sit on standby and wait for some upcoming features and so forth. So that's something that we can visit if you want to reach out to me after the call. You can certainly do that. How does the ESA work with vSphere replication and encryption? Does it encrypt the data before it goes across the link? So vSphere replication, it knows nothing about what vSphere replication is doing in terms of its activities. It's fully transparent, so there's nothing that you need to worry about there. For encryption, VM encryption, that would be a service that is double on top of any sort of vSAN encryption. And the one advantage of the VM encryption would be that you're assigning that on a per VM basis. If you don't have that need, I would just avoid that entirely. Use vSAN encryption. It is cluster-based, but it simply just makes your life way, way easier. Is there a requirement for ESA to have NVMe disks? I don't think vSAN 8 has a requirement for NVMe. Yeah, so vSAN 8 includes two architectures, the original storage architecture and the Express storage architecture. The original storage architecture still has the same requirements or capabilities that you were familiar with in terms of it supports hybrid, it supports SAS and SATA flash devices and spinning media. The Express storage architecture in vSAN 8 only supports NVMe-based storage devices. So that hopefully that clears that up for you. Let's see, does this change the way that encryption key management in vCenter is done? Yeah, there's been a few changes as far as how we handle the disk encryption key, and it's the sharing of the disk encryption key. That's sort of outside the scope of the presentation here, but there are some changes there, and it's also related to some upcoming efforts that we haven't revealed yet as well. But if you're using, like, let's say, a native key provider in vCenter server, it's going to be none the wiser. There's really no change. Let's see. Mohammed says we will replace our actual Cisco UCSC series M4 rack servers used for vSAN OSA this year. We are using vSphere 7. We'll also migrate to Horizon 8. Instant clones replacement will probably be done in Cisco's X series Blade series. Do you think we already have to take into account that the hardware is compatible with vSphere 8 and vSAN 8 ESA? Well, there's a couple of things there. If I'm reading this right, you're still considering blades. I would maybe rethink that. The blades fit a specific need at a certain time. That was the era of you were trying to pack as much computational density per rack unit, knowing that you had external storage sitting somewhere else. But of course, architectures and technologies have changed over the years. I would maybe revisit that. Will ESA support RDMA? Yes, it does, and it will. So that's good there. Is there still only one VM kernel for vSAN on vSAN 8, or can we use multiple VM kernel ports with multi-NIC vMotion? Yeah, so there's still a single VM kernel for vSAN, but what we found is that that's not the bottleneck. So yes, vMotion, over the years, you can use multi-NIC vMotion and have them sort of set up in an active sort of way, and it's just going to randomly bounce the vMotion traffic on whatever link there is. When you're talking about storage, that's a little bit more complex, and that's why we go with a single VM kernel. Now, you can use, if you want, a dedicated link aggregation that will, provide some additional benefits. Most of the benefits for link aggregation is really focused on failure of a given link and the rate of change or of that failover. But if you're focused on performance, just go with 25/100 gig Ethernet, supporting RDMA, and that's going to set you up very, very well. Let's see. Does vSAN 8 support RDM disks? The answer is no. Let's see. The Artem asks, I asked Dell about availability of new VxRail supporting ESA, and it could be available within the next half a year, but we are already building our new VCF environment with current hardware. Does it make sense to buy new clusters supporting ESA if we use the benefits of ESA? Yeah, there's some value there. You can spec out essentially an ESA ready node and install the OSA on it. And yeah, you'll have to assign one of those storage devices as a caching tier and the rest as a capacity tier. But then you have the confidence in knowing, say, when the time is right, then you can sort of make that transition over. And I wrote a paper out on core.vmware.com that focuses on migrating over to the Express storage architecture. And I show in that particular case, if you have existing compatible hardware, how you can swing over in a sort of an innovative way where you swing one host at a time over to a new cluster. So that may be an option for you.
And Pete, it looks like he asked a follow-up question there, or clarifying.
Okay. Okay, fantastic. Yes, thanks. We started building a new VCF environment based off of existing VCF and hardware. Should we buy new clusters with NVMe and ESA support? I certainly would. Really, it's the NVMe is the future. vSAN ESA is the future. There are limited reasons to sort of say, no, my use case, it's going to be best that I stick with the original storage architecture. When we were originally kind of doing the primary development, we actually thought that there might be some use cases here, but the market conditions and the capabilities and the effective results that we've seen with vSAN ESA is such that it's almost always falls in that favor. So.
And David was the one that originally asked about redirect on write. So I think his.
Oh, yes. Yeah. So the best way to think about it, the new ESA snapshotting mechanism is that it is a redirect on write mechanism through our log structured file system and the underlying data structure. For other storage systems using VMFS, they're just, left to their own devices and capabilities there. And most of the time in that case, they're offloading it to array-based, snapshotting and so forth. But you can, when you're actually interacting with the ESA-based snapshot, you'll see that it actually behaves and performs in a very similar way to an array-based snapshot that was implemented well. And I think that, boy, did we cover all the questions there, Andy?
Very impressive, Pete. You handled that like a pro. You said at the beginning that there would be a good number of questions you expected, and you called it for sure. So, but it was a lot of great content. Thank you for the really useful details, giving us a good understanding of the benefits of ESA. How do we get to ESA? You gave us a lot of great info. So thank you for your time that you've invested into this and for sharing it with us today.
No, thank you very much for having me, Andy. And again, it was a pleasure to share this information with your audience and make these presentations like this really valuable. That's what we enjoy doing.
Yeah, super. Thanks much. And to the audience, just want to remind you that this was recorded. Your TAM will make that link available to you. Thanks so much for joining us today. And please do get registered for our session next month, which again is on the topic of applications everywhere. And we look forward to seeing you then. Thank you very much.